All right, we're at time, so I'm going to go ahead and get us started. Thanks everyone for joining us. My name is Katie Boyd and I'm the program manager for CLEAN, which I'll talk a little bit more about later. And I'm just going to introduce Frank Neopold. He's the NOAA Climate Program Office Education Coordinator and CLEAN Network Co-Chair, and he's going to get us started here. Actually, really quick, Frank, before you do that, I'm just going to let people know we're going to have time at the end for questions. And so if something does come up for you in the middle somewhere, go ahead and put it into either the chat or the Q&A feature, and we'll try to monitor that as we go and address it at the end. Thanks, everybody.
Thank you very much, Katie. I really appreciate the opportunity for us to pull together a couple of really important resources and educators and focused on the National Climate Assessment. I was on the Federal Steering Committee for the National Climate Assessment, and it's a really important resource for educators across the United States. So it's a great honor that we have Dave Easterling, who is currently the director of the National Climate Assessment Technical Support Unit at NOAA's National Centers for Environmental Information. Dave, I've still not got that down. I still want to say NCPD. But I didn't, but I did. In Asheville, North Carolina. So Dr. Easterling was a contributor to numerous IPCC reports over the years, and also was a key part of 3 of the 4 national climate assessments. His research includes detection of climate change and observed record, and particularly changes in extreme climate events. So it's a great honor, and remember everybody that we have a group with us tonight in a live recording, but then also we're going to be posting this on the CLEAN website and climate.gov, so that this is useful for thousands potentially and tens of thousands of teachers across the nation, not just those who are with us tonight. So Dave, I want to give it over to you. And
actually, Frank, we wanted to do our poll first. Do you
mind yes. Thank you, Katie.
Yeah.
Thank you. Sorry, I missed that little detail. So let's pull up the poll and please give us a sense of where you are. And we're using the National Climate Assessment regions. So some of this is going to be a little bit of a guess for some of you who are on the edges. We'll see if everyone is accurate, but let's give it the whirl.
Yeah. And the poll is going, so please respond when you can, and we'll leave it up for maybe a minute here so that we can get everybody's responses in. And we're almost at 30 seconds, so we'll go for another 30 here. Ten more seconds. We got almost everybody in. Please put your vote in if you haven't yet. All right. Looks like we have most people from the Northeast. Got another good group from the Midwest, 20% of you, but almost half from the Northeast. And then we got about 10% each from the Southeast and Southern Great Plains, and then a smaller percentage from the Northwest and Southwest. Thank you all. It's great to know where you're from.
Well, thank you very much, Katie. Is it possible to...
oh, I'm sorry. Did I not share those?
Yeah, there it is. Popped up. All right. Well, that's... and it'll be interesting to see. Maybe I wonder if we could put that up toward the end just to see, because probably still more people are going to be coming in, but we'll chat about that.
Yep.
But that's a great mix.
All right. So let's give it over to Dave then.
Dave, to you, please.
Okay. Thanks, everyone. And what I'm going to talk about today is the 4th National Climate Assessment. And the National Climate Assessments are required by law. So the 1990 Global Change Research Act that was passed under the first President Bush, in the act required that an assessment of the impacts of climate change on the United States be done every 4 years. Unfortunately, the first one didn't come out until 2000, so it took a little bit of time to get going. The next one came out in 2009. The third one came out in 2014, and now we're more or less on that 4-year cycle with this one coming out in 2018. There are actually 2 volumes to the fourth National Climate Assessment. You see here the cover for volume 2, which is impacts, risk, and adaptation. So basically it's climate's changing. What does that mean to people, to ecosystems, to the economy, and that sort of thing. You can see here that at the bottom is the web address, nca2018.globalchange.gov. The next, let's see, here we go. Volume 1 was actually what we call the Climate Science Special Report. And this is a very comprehensive report of what the climate system is doing and what we expect it to do based on the fact that we've had increases in greenhouse gases, we've seen warming of the climate, and I'll show you a little bit of that about that in a minute. You can see here that reference to the Global Change Research Act. This is a very comprehensive scientific document that goes over all the different parts of the climate system, physical drivers of climate, detection and attribution, which means can we detect a human fingerprint on the climate system and the changes we've seen. And I'll talk a little bit about that in a few minutes. Projection for the future and so forth. And here's the web address at the bottom, science2017.globalchange.gov. So this is actually a 2-volume report, whereas the other, the previous 3 were actually just 1 volume that contained everything. But we decided that we wanted a more comprehensive report to start off and looking at how climate is changing. Okay, so volume 1, which is the Climate Change Science Report, is the most comprehensive and up-to-date assessment of the state of the climate science today. So it had contributions from 12 federal agencies, 50 authors. It was almost 500 pages. And all these reports are subjected to a lot of review. So we had a public review, we had 2 agency reviews. So all the different agencies in the Global Change Research Program actually reviewed it. And then we had a National Academy of Sciences panel that reviewed it. It was released in 2017. Volume 2, which was just released in 2018, actually at the end of November 2018, is the most comprehensive and up-to-date assessment of how climate change is affecting the U.S. And how we're responding. So it's impacts and adaptation and mitigation, what's happening on various sectors such as the economy, agriculture, water resources, and also region by region. As Frank said, that there are a number, this report is broken up into regions as well as sectors, so there's a lot there. A lot of information. Again, 12 federal agencies contributed. We had over 350 authors for this report for the volume 2, and it's over 1,600 pages. And it was also subjected to the same public and multiple agency and National Academy reviews as the Climate Science Special Report. And I said, you know, this one was released in November of 2018. So the 2 together are well over 2,000 pages, and they're very comprehensive. There's a lot of information there. The one thing that we did try to do, especially for volume 2, which is the impacts, is to write it at a level that somebody that is about a freshman in college, had a little bit of science experience, would be able to understand. We may not have been successful all the time, but that was the intent. So it should be fairly accessible to people. Okay, so what does it say? This is one of the few graphs that I'm going to show that's not in one of the reports, because I wanted to show an update to this graph. And this is something that we do at the National Center for Environmental Information in Asheville. We're the world's largest archive of weather and climate data, and we also use that data to monitor and analyze the climate for past climate change. This is one of the graphs that we put out every year, and actually we put out every month, looking at the monthly temperatures. But this is the global land and ocean temperature anomalies for annual. So this is the annual temperature. So if you average everything up into one number for the year, this is what you get. So this is a combination of, over land, we have data from temperature data from observing stations at climate stations at airports all over the world, and we use that for the land. And then for the ocean, we average up sea surface temperature data that we get from ships and from satellites and from buoys, and come up with this one number for the world. So 30% of that is over land. It's the temperature from the observing stations, and 70% of it is from ships of opportunity. So you have all the merchant ships that are out there, and even back into the 1800s, these ships would drop buckets over the side, lift them up once a day, note their latitude and longitude and what the temperature of the ocean was. All these were then recorded in the ship's logs. These ship's logs we've ended up with here at the center, and we've digitized them and put them into big data sets. And so that's what we use to analyze. So this shows you this one number for by year, this starting in 1880 to the present. And basically showing you what's happening in terms of this overall number for the climate system. You can see from 1880 to about 1910, temperatures cooled a little bit. They warmed up to World War II, actually got a little flat and kind of slightly declined. There's a little bit of a data problem in World War II here. But since 1970 or so, temperatures have been going up at a fairly steady rate. And that's where we've seen the biggest increases in greenhouse gases as well. So you can see the steady rise from 1970 to the present. You can see here that 2016 was the warmest year on record, and then 17 and 18. But the four warmest years have been since 2015. Okay, so where is it warmed? This is a map showing surface temperature change since 1901. And one thing to note, that changes are not uniform, and we don't expect them to be uniform based on what we understand about how the climate system is going to change. You can see here off the coast of Greenland, this little bit of blue would actually indicate a slight decrease in temperature. And if there's a little tiny bit of blue here in the southeastern US and a little bit up here, but you can see that overall the pattern is warming, and the warming is at the highest latitudes, and that's what we expect. We expect the tropics not to warm a whole lot. There's actually, if you look at the energy distribution across the Earth, there's an excess of energy coming in the tropics and a deficit at the poles, and we have to be able to move energy from the tropics to the poles. That's what storms do, the atmospheric circulation does. But we see the greatest forming here at the highest latitudes. And one of the reasons we expect that to happen is because of feedback mechanisms in the high Arctic and the Antarctic, where just a very simple example is if you have a snow-covered region, the incoming energy from the sun is easily reflected back out to space by the snow because it's white, bright white, very reflective. As you begin to melt back snow cover and sea ice, you're exposing more of the land surface that absorbs that energy instead of reflecting it back. And so you begin warming it up, and it begins kind of feeding back on itself. So that's one of the reasons why we expect the higher latitudes to warm the most, and that's what we're actually seeing in the observed record. Okay, so why is it warming? So the greenhouse effect, there's a natural greenhouse effect that keeps temperatures on Earth around, on average, if you think back to that time series I showed, on average about 58 degrees Fahrenheit. That's because we have an atmosphere. And the greenhouse gases, the main ones are carbon dioxide, methane, and nitrous oxide. And we're seeing an increase in these greenhouse gases. These greenhouse gases keep the atmosphere a little bit warmer. They absorb some of the outgoing energy from the Earth's surface. And if you increase the concentration of these greenhouse gases in the atmosphere, you, by definition, have to begin warming the climate. And that's what we're seeing. This bigger graph here is atmospheric CO2 is measured at the Mauna Loa Observatory in Hawaii. So this is up on top of the Mauna Loa volcano. It's been there since the late 1950s. And CO2 measurements, the reason it's up at about maybe 11,000, a little over 11,000 feet. So you're pretty high up in the atmosphere. And when you're that high up, you're able to measure what we call sort of the background concentration. That's well mixed because you're up above a lot of the turbulence is going on in the boundary layer next to the Earth's surface. So what you're able to do is get a good idea of what the global concentration of CO2 is, as opposed to what you might be measuring because you're right next to a car or something. And what this shows is this very steady increase in carbon dioxide since 1957 to the present. And it is now over 411 parts per million. It started off in the pre-industrial time. This was back in about 1850. It's somewhere around 270 parts per million. So we've gone up that much, from 270 to 411 parts per million over the life of the Industrial Revolution. Where's the CO2 coming from? As well as methane and even nitrous oxides, is coming from the burning of fossil fuels. As you burn coal, as you burn petroleum products, you're emitting carbon dioxide and methane and nitrous oxides and other greenhouse gases into the atmosphere. So this is probably the biggest reason why we're pretty confident, and I'll talk about this in a few minutes too, why we're seeing this increase in temperature. And along with the increase in temperature, we're seeing changes in other parts of the climate system, which I'll show in a few minutes. Okay.
I'm going to interject Dave here a little bit. This is Katie again. I'm just going to introduce CLEAN and how you can use it to help you teach about what Dave is presenting about and talking about today. So CLEAN has three main components. The first being the CLEAN collection of resources that have been reviewed by scientists and educators. Then we also have our teaching guidance. This has background information and tools and resources you can use for teaching about these topics. And then the CLEAN network is a community of practice of climate and energy literacy educators and stakeholders. And Dave, if you wouldn't mind pushing me forward. So the teaching guidance, as I mentioned, has these pages. If you clicked here on teaching climate or teaching energy, it'll take you to pages that outline each of the climate literacy or energy literacy principles. And these are the big ideas you kind of need to understand climate and energy topics. And then we also have the toolbox that includes some resources I'll talk a little bit more about later, like our NCA teaching page. And then we also have webinars. So if you want more information about any of our resources or how to search the collection or this guidance, check our webinar page and other resources there. One more slide, Dave, please. So if you went into the actual teaching guidance pages, this is what Dave just has been talking about. One of our climate literacy principles, number 6, focuses on this idea of how human activities are impacting the climate system. So here you can find background information for this topic, how to teach it, challenges for students, etc. And so if you click one more, Dave, you can also then find activities relevant to this principle in our collection. One more click. And so it takes you down to the bottom of the page where you can then search by grade level or just search all grade levels. One more click. And this will take you into our CLEAN collection. Here we have a curated collection of resources. So we don't develop these resources, but we go out and find good resources that we think will be useful for teachers to teach about climate. We put it through a review system. So we have scientists and educators. We have multiple steps that it goes through in this review. So multiple people look at it. And then we have a final review where an expert scientist in the field of that topic in that resource looks at it as well. So you know that these resources are quality in terms of their science as well as their pedagogy. We also try to find things that are classroom ready, that are free, easy to use, etc. So we think these are all things teachers would be excited about finding. And then finally, we align them with things like the next generation science standards and those big ideas, the literacy principles, and try to tag it with all these things to make it really easy to search through. So I'm gonna let Dave talk a little bit more about the NCA, and then we'll come back to some activities that help highlight the things he's gonna talk about. Thanks, Dave.
Okay, thank you, Katie. Okay, so I showed you the global temperature time series and the fact that it's warming, and then increases in greenhouse gases. There are other indicators of climate change. As I said, climate change is not just warming of the climate. It's going to have impacts on other parts of the climate system. And one of the most iconic ones is Arctic sea ice decline. This shows you a satellite image showing you September Arctic sea ice in 1984. You can see how much of the Arctic is covered in ice. And here we have it in 2016, where all this area in here that was covered in 1984 is no longer covered with ice. This is in September as well. September is when you have the lowest amount of sea ice cover in the Arctic because of melting through the warm season. And this graph here shows you the Arctic sea ice extent as measured from satellites in millions of square miles. And so you can see that in about 1980 or so, we were at over 3 million square miles in the Arctic. And there's been very steady decline to the present. So we're down to less than 2 million square miles of sea ice in September. So when it's melted back the most. So one of the impacts of this actually is that people are beginning to look at shipping the so-called fabled Northwest Passage through here. I'm not sure, it's actually kind of in amongst these islands, because it would cut the route from Europe to Asia probably down to a third of what it currently is if you go through the Panama Canal, or even more so if you go all the way around South America. So this is one of them. Sea level. So sea levels have been going up, and it's gone up about 8 inches since about 1920. This is averaged around the U.S. coast. If you look globally, and I'll show you a graph in a little while looking at global sea level, but you can see that little fits and starts here. That's sort of what we call natural variability. These are changes in ocean currents when we have increases in the Gulf Stream, things like that. But overall, we've seen this increase in sea level of over 8 inches since 1920. And that is beginning to have impacts in the U.S. And one of them is what we call tidal or nuisance or sunny day flooding in places like Charleston, Miami, Savannah, a lot of the coastal places along especially the East Coast, but also in other areas. But this just shows you an example in Charleston of what we call sunny day or nuisance flooding, which have increased 5 to 10-fold since the 1960s. As we've had, this happens actually when you have a very high tide, and because of sea level rise, it begins to spill over onto the streets. And I know in Charleston, they're having to spend many tens of millions of dollars in building a drainage system to be able to account for this. So it's beginning to cost real money. Okay, what about observed U.S. temperature change? I mentioned places that cool. So this shows you temperature change 1901 to 2015 in the U.S. It shows you by region. These are the NCA regions, with the exception of this one is actually cut, I think, right here. So the Great Plains used to extend in the NCA 3, the third National Climate Assessment, it was one big region. Now we've cut it in two into the northern and southern plains. But what this really shows you is that the U.S. is warming pretty much everywhere, and in some areas quite a bit. You look at Alaska, it's warming a lot. The only places that are cool, showing any cooling, this is actually almost in the world, except for off of Greenland in the ocean and a couple of other select areas, is in the southeastern U.S. and specifically in Mississippi and Alabama, and a little bit up here in Oklahoma. Everywhere, and why this is happening is something that we've been looking hard at. It could be due to aerosol increases from power plants, sulfate aerosols that are produced by power plants. These little particles get up in the atmosphere, they actually reflect back some of the incoming energy from the sun, and that can cause cooling. If you have a volcano go off, like Mount Pinatubo went off in the early 1990s, that actually had a global impact on the temperatures around the world, so that there's a little bit of cooling. Why this is happening though in the Southeast is unclear. If you look at the time series of the Southeast, which is this sort of histogram over here, you see it was warm in the 1920s and 30s, cooled off, but it's beginning to warm again. So my expectation is in the next 15 to 20 years, even the Southeast is going to show warming. So everywhere is showing warming in the U.S. pretty much. Okay, what is that leading to? It is actually leading to things like a change in the growing season length. This map shows you the change in the growing season length in days since the late 1800s. So we have good climate observations from around the U.S. Starting in about the 1880s, 1890s, when the U.S. Cooperative Observer Network was put in. And you can see some of these areas have had very large changes in the length of the growing season, defined by the last spring frost and first fall frost. Some increases of almost a month in some of these areas. The only places you're seeing any kind of a decrease is here, again, in the southeast. So it is having an impact. I mean, this could lead to things like double cropping. If you're a farmer, you may actually be able to grow 2 crops instead of 1. But eventually, it's going to cause major changes in ecosystems, because if you think about the way plants are distributed, and if you think about the planting zones that USDA puts out where you can plant different kinds of plants, they're changing. They're changing because of things like this change in the growing season. Okay, what about other parts of the climate system? So we have observed, this is some work that we've done here at our center, looking at changes in heavy precipitation events. These are 24-hour events all the way up to, say, 5-day events, where we've seen large increases in the number of these events over time. And if you're looking at the Northeast has seen the largest increases in the numbers of these events. And we also have seen them in the Midwest, also in the Southeast, less so in the Southeast or Southwest. Southwest has actually gotten drier over time, but they are still seeing an increase in these heavy rainfall events. And that's something that we expect to happen in the future, because as you warm air, the climate warms up, the air can hold more moisture. And so you get more evaporation, more moisture as temperatures go up, and there's more moisture to rain out in heavy rainfall events. And this is a good example of what's been going on in the Texas area. This is showing you Hurricane Harvey from 2017. Over a 4-day period, it dropped almost 50 inches of rain in the Houston area. And this is just an example of what happened. And not only that, on the heels of Harvey, last year we had Hurricane Florence in the southeast coming in through the Carolinas, not dropping quite as much rain as 50 inches, but almost 30 inches in a lot of the areas as well. So this is just a good example of what we're talking about with these heavy rainfall events.
And here I'm going to interject Dave one more time. So a lot of these things he's talking about, these impacts of climate change, relate to Climate Literacy Principle 7. So I tried to find some activities to help highlight this. And the way I did that was, as I mentioned before, I actually went to our Literacy Principle page and then clicked on this Find Activities. And Dave, if you could just click once more, it'll pop up here. This was then the search that I did. So one of the things he mentioned was sea level rise. So I decided to do that as my text search. You can see that this at the bottom of the page, this climate literacy principles tag was in there. So that's from going out of the climate literacy principles. And then I chose high school. And I also wanted to highlight another part of our collection. We have things tagged whether there's data set use. So this is showing activities that have students using real data, which is a nice feature that we have that to search by. And then on the right of these search, you can narrow these down by these different tags. And another way we like to narrow it down is using resource types. So I put that here to highlight that in our collection we have lesson plans, we have short demonstrations or lab experiments, we have videos, we have visualizations, we have a bunch of different resource types you can search by as well. So I'm going to highlight a few of those. Dave, if you'd click once more. So here's an example. This is a visualization that comes from the NSIDC, the National Snow and Ice Data Center. They've put an animation to the sea ice decreases that have happened in the Arctic. And so that's a nice resource to use just to showcase that data. However, it doesn't have a lot of scaffolding or teaching facilitation with it. So the other thing that's nice about Clean is that because all our resources go through this review process I mentioned before, we gain information about the resource that we then put on our website. So if you click once more, Dave, you can see, so there's a description, there's how long it takes, and then there's some notes from our reviewers where we talk about the science and the pedagogy behind each activity. And then we have this section called teaching tips. And actually this was a nice one to highlight, because in the teaching tips section, there was another resource you can see in red there. And if you click once more, you can go to that resource, and that actually brings up a lesson plan that has students graphing sea ice extent. So just a nice way to highlight another activity here that you could use instead of just the visualization if you wanted to have something more in depth. And if you click again, this is an example of a more just either lab-based activity or demonstration a teacher can do using water. This from the National Weather Service. They have students sort of model the water cycle and then talk about flooding that Dave was just mentioning is a huge issue with climate change. And if you click once more, I have one more classroom activity here that is from the NIH that talks, this is something Dave didn't mention, but is also really important and is part of the NCA, is this idea of the impacts on health as well. So this activity is students explore health impacts of climate change and what happens if we can help mitigate that. So thanks, Dave. I'll send it back to you.
Okay, thank you, Katie. Okay, so I mentioned early on the increase in greenhouse gases. So why are we confident that human emissions of greenhouse gases are the dominant cause of warming? So this is one reason. So if you look at all the different indicators, and when I say indicators, it's things like changes in water vapor or changes in sea surface temperature, or changes in sea ice. So all the indicators that are expected to increase in a warming world are increasing. So we have water vapor increases observed. These are all observed. We have air temperature near the surface. So this is measured from satellites. We have temperature over the ocean, temperature over the land, sea levels going up, ocean heat content. So ocean heat content is the energy that's in a layer of the ocean between about the surface and all the way to the bottom. But we measure, what we're talking about here is down to about 700 or 800 meters deep. And we do have measurements of that. That's going up. Sea surface temperature is going up. The things we expect to decrease, glaciers, such as alpine glaciers, are declining. Snow cover is declining, and sea ice is declining. I mentioned that earlier. So all these things are consistent with a warming climate. So this is one reason that we can kind of attribute this, as what we call attribution, to the increase in greenhouse gases and also changes in land use. The other thing is how we can use a climate model to simulate the observed temperature time series that I showed earlier. So you think all the way back to the beginning to that graph I showed, showing the global temperature time series, the observed from 1880 to the present, and it does show warming with a bit of some fits and starts in there. So the only way to get a climate model to simulate that time series is to include observed increases in greenhouse gases. Okay, so this is a figure from the National Climate Assessment. Okay, so this black line is the observed record that I showed you earlier. And then these are also global temperature time series from models that are averaged up over the entire globe. But these models are run using what we call different drivers or forcings. So here we have volcanic forcing. So when a volcano would go off, in the model we would throw in sulfate aerosols and particulates and stuff like that, see what it did to the climate. It does cause cooling. We have observed changes in solar energy coming in from the sun, orbital changes. So this is direct measurements of the solar, but we also have orbital changes because of changes in Earth-Sun relationships. You know, the tilt of the Earth's axis, how where the axis actually points, and how circular or elliptical the Earth's orbit is around the sun. All these. That's how you actually end up getting the ice ages and the interglacials, is those various things. But if you include all these natural drivers, nothing leads to warming. Okay, here we have the observed, and here we have these modeled time series, and none of them lead to this warming. This one is showing you human influences. So we got greenhouse gases. You can see with this purple line, we got changes in ozone, Actually, these two aerosols, I mentioned aerosols from volcanoes, and they also come from power plants. These are sulfate particulates, little tiny particles of sulfur that are injected into the atmosphere. When they get up in the stratosphere, they actually reflect back incoming energy from the sun. So that actually leads to cooling. And then land use change, we think also ends up leading to cooling. Ozone doesn't really lead to, it leads to a little bit of warming. But you can see greenhouse gases actually exceeds the observed warming, okay? So what's happening is greenhouse gases are forcing this much warming, but these other changes, land use and aerosols, are actually causing a little bit of cooling. And as a consequence, you end up getting this. If you include all of this and all of this into a climate model or a number of climate models, that's the only way that you can actually mimic or reproduce the global temperature time series. You can see all these fits and starts, and look how closely, this is a numerical computer model, very complicated, that actually is able to reproduce this observed temperature time series. And the only way you can do it is to include all the natural influences and all the human influences. And these are the big drivers. The greenhouse gases, you can see, are the biggest reason why we could fit this right here. So that's another one of the big reasons why we're very confident that human emissions of greenhouse gases are leading to warming. Okay, so how do we predict future climate conditions? We don't have a crystal ball to be able to look into them, so our crystal ball is a global climate model, which I was just talking about. These are very large, complicated computer programs, hundreds of thousands of lines of code that solve various equations at thousands of individual locations covering the globe, and also different layers in the atmosphere and the ocean. So it's very comprehensive, trying to simulate all the winds and the temperature and storms, humidity, circulation of the atmosphere, all that within a computer model. And they're getting very, very good at it. And this is projected global surface temperature change. This is from the volume 1, and I think this might also be in volume 2 of the National Climate Assessment. But these are from a whole suite of models. So what happens is there are quite a number of modeling groups around the world that these are all run on supercomputers. And there are about 5 or 6 big modeling groups in the US. There's 3 or 4 in Europe. The Chinese have a couple, the Japanese, and so the Australians, and so forth. They all have modeling groups, and they use these scenarios of how we think greenhouse gases might change in the future to then begin taking a look at how it's going to impact the climate. And that's what this graph shows. So RCP 8.5, this is just sort of an acronym for what we would call business as usual. Greenhouse gases continue to increase at about 1% per year into the future. We don't really do a whole lot to reduce emissions. This intermediate scenario, 6.0, means that emissions eventually begin to be reduced through the 21st century, and it does have an impact on temperature. 4.5 is an even lower one, and then 2.6 is even lower. So 2.6 means that we suddenly stop emissions or drastically reduced emissions of greenhouse gases starting next year. Okay, so that's what this range spans from. We don't do anything to we drastically reduce emissions in 2.6. And then the black line is the historical record. And so here we see the historical record from 1900 to the present. And then from this point on, in the early 2000s for these model runs, you can see how the different emission scenarios lead to different increases in temperature. So if we don't do anything, we just continue to emit greenhouse gases. That's what this red line is. And this shading is the fact that this is an average from all these different modeling groups for the results from their models. And they all show warming, and they show anywhere from this much warming, which is somewhere around 3.5 degrees Celsius, to almost 5 degrees Celsius averaged over the entire globe. If we have this much warming, you're going to have major, major impacts to things like extremes, storms, and the sea level rise. Just about anything that I showed earlier is going to have a major impact on that, which is then going to have a major impact on society and natural systems. if we begin to really reduce greenhouse gases a heck of a lot, we're in store for about another degree of warming. Okay, so we have a range from somewhere around a degree of warming to up to as much as 5 degrees of warming, based on these computer simulations. Okay, that's also going to, like I said, lead to changes in other parts of the climate system. I mentioned sea level rise. This is really one of the major ones, along with changes in storms and things like that. This shows you, this is the globally average. I showed you earlier the US time series from all the different coasts. This is from 1800 to the present. Okay, this is global average sea level reconstructed from proxy records, where paleoclimatologists have gone in and taken sediment cores and things like that to reconstruct sea level. This is tide gauge data that at various places along the coast, they have tide gauges. And then we have satellite data, which is really the most accurate. And you can see that we've gone up almost a foot since 1800. Okay, now if we continue warming the climate, we expect sea level to go up anywhere from a foot if we really stop emissions now, and the climate system really kind of slowed down and didn't continue to warm much, all the way up to as much as is 6.6 feet, or about almost 2 meters. And it could even go up more. There's a lot of uncertainty in these numbers because there's a lot of uncertainty about what might happen to the Greenland and Antarctic ice sheets. If they really begin to lose ice mass like they are doing now in the observations, we could see even more sea level rise. So, but it's going to go anywhere from a foot to as much as 6.5 feet.
Dave's just been talking about models, so I just wanted to show a couple of modeling activities we have in our collection. This is an activity that allows students to use a simplified climate model to explore some of this on their own. And then if you click forward, Dave, this is just an example of then if you didn't want to have a full activity, but you might want to do something around climate models. We have things like videos. This is a 5-minute video that you can use to talk about or just introduce the topic of climate models in your classroom. Thanks, Dave.
Okay. All right. So we have seen climate change and the observed record and how it might actually change in the future. How is it going to impact our world and what can be done about it? So this is just a little bit from the volume 2 of the 4th National Climate Assessment. Okay, so this is showing you annual economic damages all the way out in 2090 and changes the number of hours worked. You can see that everywhere would show, and this is mainly based on the environment. As you go out, you're not going to be able to get outside as much if it really warms up, especially in some of these areas in Texas and Florida. So this is the expected change in hours worked in percent. And so you see as much as a 5% change, decrease in the number of hours people are able to work. This is averaged up over the country for 2 different scenarios. This is what we call the business as usual, where we really don't do anything about greenhouse gases and we get that drastic warming. You can see that in billions of dollars, this is going to have a major impact on the economy. If we begin to get it together a little bit and reduce emissions, it'll have an impact, but not as dramatic. This shows changes in 8-hour ozone concentrations. Ozone is bad for people, especially that have respiratory problems. And so you can see that some of these areas are going to have pretty large increases in ozone concentrations. Okay, coral bleaching. So this is showing you projected coral bleaching for the U.S. affiliated Pacific Islands and the year of onset. So that's what this shows here. This is the expectation. So coral bleaching is where a lot of the organisms that give coral their color and everything begin to die off because it gets too warm. The ocean temperatures get too warm. And this shows you the expected year of onset. You can starting in about 2030 all the way out to 2044 for some of these areas around Hawaii, the Northern Marianas, Guam, and American Samoa. You can see that we expect to see coral bleaching in the next few decades. This is another example of adaptation, not a good one necessarily. This is community relocation for Isle de Jean Charles, Louisiana, and where a federal grant is being used to relocate this community off of this island here because of sea level rise and land subsidence in Louisiana. The areas are becoming uninhabitable. Okay, this is an adaptation measure in Alaska. Kivlina, Alaska is actually up pretty far up on the northwest coast. It's above Nome, and you can see that they begin having to put in these revetments, these big rock barriers, because a large part of it is because they're getting a lot of erosion in this area because of the Arctic sea ice retreat in the wintertime. Arctic sea ice is not extending as much down into this area in the wintertime, and so they get these winter storms that produce large waves and begin to erode back the shoreline. Okay, what's being done about it? And this is an interesting sort of question, because a lot of people ask me, okay, what's being done, say, at the federal level, since I'm at the federal level? Well, there's really a grassroots effort around the country to begin mitigation related activities at state and local levels. A lot of these, you can see these are examples of cities that are supporting emissions reductions. And so a lot of states and municipalities are actually beginning to put in their own mitigation plans. Okay, so just to finish up, so we get some time for questions. There are both positive and negative impacts to global warming. Like with any change, there's going to be a few positives, probably not for long, but some. But overall, the net impacts are likely to be negative. So you're going to see increases in heavy rainfall events. You're going to see increases in very hot days. They're going to have impacts on people's health. Ecosystems have evolved and human systems are adapted to the current climate. And that's what the big issue is. A lot of people say, well, the climate has always changed. Well, it has. You know, we've had ice ages, we've had interglacials, which we're currently in, but the current ecosystems and human systems, all the natural systems are adapted to the current climate. And if you have very rapid changes in the climate system, you're going to have major disruptions in ecosystems and human systems. I always like to kind of finish the talk up with this cartoon. It's always a little bit kind of funny, big hoax, because I certainly have heard a lot about it being a big hoax. But even if, you know, if you don't really believe necessarily that it's a big deal in terms of the fact that humans are causing it, it's still an issue. And addressing the climate and how it's impacting human systems and natural systems is a good thing.
So this is my part again. Thank you so much, Dave. And I'm just going to take a couple minutes here to highlight some of the teaching resources we have around the actual National Climate Assessment. So on CLEAN, we've updated our page here. And so this is just a screenshot. We have the sort of read more about the findings of the report. So we've taken the executive summaries and each of the chapter findings and tried to sort of lay them out with links back to the report. Same with the the regional the chapters on the different regions. So in the map, you can link back to the major findings that are in the report there. And Dave, if you wouldn't mind just clicking again for me. Climate Generation, I wanted to highlight them. They did a lot of work around the last climate assessment when it came out. They have this whole unit around teaching climate, and lesson 3 includes some activities for doing like a scavenger hunt and trying to get your students to find things in the National Climate Assessment. Again, this hasn't quite been updated yet. We're all working on trying to update our things, but still relevant, and I think can be easily adapted to the new report. And Dave, if you'd click once more for me. NOAA also did a huge created a lot of resources around the National Climate Assessment, and those are on their page, again, in the process of being updated, but still very relevant and useful, including they have one specifically that helps talk about which NGSS have been addressed in the National Climate Assessment. And then the final bit we're going to do here is I'm actually going to throw it over to Luann Dahlman. She's the co-managing editor of the Climate Resilience Toolkit. And Dave, if you would click once more for us, that'll show you this. She's going to talk a little bit about the Climate Explorer. She's a user advocate for their team. So Luann, if you could tell us a little bit about that, and maybe we can switch the screen share in here.
Yeah, there we go. Is my screen showing?
Yep.
Alrighty. So one of the things we did to make things easier for people is I worked with the folks at the US GCRP, and let's say you're reading along in chapter 25, because I'm in the Southwest, of the National Climate Assessment, Volume 2. In the human health section, and see there's a little graphic here. It turns out the graphics throughout the NCA4 are really a great opportunity for data literacy practice. So this one, for instance, it shows the increase in average number of days per year when the temperature exceeds 90 degrees during a period centered on 2050 compared to another period. And it shows the Southwest, but maybe you were interested in a different time period than the 2050s, or maybe you are from over here in Texas. The report is a static report. So what they did is they said, well, we have a lot of other information and we can make access to it with these little icons. So right here, the sea-related content from the US Climate Resilience Toolkit, clicking that gives you the opportunity to leave that site and open a new one. I have to get rid of my... Oh, sorry, I have to move that out of my way. So once you click that, it actually takes you to a page that shows the very same graphic that you were looking at in the NCA4, and it tells you what you were looking at there, and then points out that you're going to have an opportunity to look at something similar within the Climate Explorer. So the NCA figure shows the increase in number of days above 90, but there's always a little description here. The difference is the Climate Explorer will show the annual number of days over 90, 95, 100, or 105. So it gives you a little more flexibility and a few more features. And so looking at this, it gives you some instructions. This is actually set up as a story map. I have this left-hand margin where I can give instructions, but it's the Climate Explorer in the other of the screen. So the first thing it says, check the numbers on the color scale to interpret the map so that you're sure you're understanding days over 90 up to 200 in places. And then it says, select the views of interest from the drop-down menu. I'm just gonna, I guess I'm having a few issues because my features are covered by the webinar things. I apologize. Okay, so
Sorry
over here,
that, Luann.
yeah, it's all right. I didn't practice that way is all. So on the left, I have the historical or lower emissions or historical version, actually the average from 1961 to 1990. And on the right, I can select either the higher emissions scenario or lower emissions and select a time period. So if I want to look at the 2050s, I can select that. And then I know what I'm comparing, and I can use the swiper to see how things will change. Now, if you want to really zoom in on your own location, and since I'm in Arizona, that's what I'm going to do. You can use the colors to estimate how many days over 90 we currently have. And if I look at that compared with the data scale, I'd say, you know, right in the 140 to 150. And then with high emissions in the 2050s, It looks like we would be more in 200 days per year over 90 degrees. That doesn't surprise people because it's Arizona after all, but that's why we have different thresholds. So you can look at, for instance, will we have days with a maximum over 105? If I switch to that, I can see that in the historical period, the average from 1961 to 1990, I was in the maybe around 60 days over 125. But if I say, again, in the 2050s, that stretches to over 75. And if you want to see the scary things, you can go all the way out to the 2090s and zoom out and see that a lot of places are likely to have many days over 105 degrees. So the Climate Explorer always, each one of these has a little try this where it asks you to do essentially what I did for Arizona. Look at it and see if you can figure this out. It's a data literacy exercise. How many days in the late 1900s? How many in the 2090s? So this entire, there's also a table of contents for the Climate Explorer story map that shows the other things that are available to look at. These are all connected to the NCA4, just like the one I showed. And there's also some general information about reading and using Climate Explorer, what the graphs mean, how to read them, and then even more about it, some of the other features that are available within the Climate Explorer. So this is a nice jump off point from the NCA4 to encourage more data literacy and exploration of your own location. And that's it. Thank you.
Thanks, Luann. So we're going to send it back to Frank, and I know we're running a little behind here, but we'll do some questions and discussion here.
Thank you, Katie, and thank you, Luann and Dave. That was excellent and impressive work. So we're going to open it up to some questions. We've been dealing with some of them, some technical, some subject matter questions in the chat, but this is an opportunity for those who are attending to ask a question. So does anybody have a question that they want to put forth?
And I know we've had a couple come through the chat so far, and so if you felt like your question wasn't answered in the chat, I think, let's see, we had one about the emissions, wasn't it? Yeah.
Yep. Yep.
Comparing the 3 greenhouse gas emissions, and then we had another one about this idea of doom and gloom and what can we do to help make things more positive for students. Maybe we could try to address those if there isn't any more coming in.
You know, I mean, maybe Dave, what do you think about this subject? I mean, you've been working in this field for a very long time. It can be very heavy and overwhelming. We're talking about very serious things. So when you're thinking about teachers working with students, how would you approach, and maybe this isn't a fair question to you, but how would you approach the whole doom and gloom aspect that is very present with this topic?
I would probably emphasize that we need to start taking, if we do start taking action now, in the next 5 to 10 years to reduce greenhouse gas emissions and deal with it, then it's not all negative. I mean, it is a heavy, if you want to call it, it's a very concerning subject because if you look at the projected impacts, I mean, there's no way around it. You know, if we don't begin reducing greenhouse gas emissions, we're going to see major changes to the climate system. And like I said, you know, there, at least initially in agriculture, there could be some positive things. With any change, there's always somebody that's going to be a winner. But the bottom line is the large majority of us, especially because, like I said, you know, the natural systems and the human systems right now are tuned to the current climate. I mean, we grow certain types of crops in certain regions, and because they're conducive to growing those crops, the crops thrive there. And if you begin warming the climate, you may have to change. That's one thing. You have to adapt. Um, you have to begin adaptation measures. You have to begin planting different kinds of crops. If you can't plant a certain kind of crop now because it's too hot, then you plant something else. You begin building seawalls and taking adaptation measures like that. You also, so it's something you got to be very upright, forthright in saying that this is a serious issue. But if we do begin acting right now in the next 5 to 10 years, then we can begin heading off some of the more serious impacts.
So Dave, there was an interesting way in figure 29.1 of the mitigation chapter, you showed it. Is it fair to say that if we begin to reduce, is it fair to say that because that shows that we are already reducing, just not everywhere. Is that a fair way to say that from your perspective?
Reducing, you mean emissions?
Yeah.
Yeah, I mean, there are, and that's a good point. I mean, so there's not been as much, let's say, federal effort in this, but it's beginning to be a grassroots effort. Municipalities are developing their own emissions reduction plans. States, especially California, are really beginning to see that it's an issue and saying, even North Carolina, where I live, the governor has just said that he wants to reduce emissions to virtually nothing in the next 20 or 30 years. It's maybe unrealistic, but it's a start.
Right. So there's one other question. I know Katie, should I indulge this one more question, or? I can't hear you, Katie.
Sorry, I'm muted. I think so. I think if people need to leave, this is a point where, thank you very much for attending. And let's go ahead and answer one more question for those who can stay for that.
Fantastic.
And everything is going to be recorded. So anyone who wants to listen to that later, it's going to be on the recording.
That's right. And the link will be sent to you after the webinar. I think within a day, they send an email with the link to the recording. So everybody will get that.
So thank you. The question that I think it's important when we're thinking about teachers, the question came in is, how do we address the population of parents who are politically misinformed to make difficult for me, a teacher, to educate with data about climate change? So, whether we put politically misinformed or scientifically misinformed, I think, but when we're talking about teachers who are struggling with, there could be a member from another department, it could be an administrator, it could be a parent, it could be, where they're really taking issue with the findings that we have in this report and this issue at hand. How do we support teachers to educate them with the data? What's your sense of that, Dave?
Well, I always try to go back to the fact that, there's a huge number of climate scientists out there that almost all, are, they've done research in it. They understand the climate system. There's a lot of scientific evidence to back it up, a lot of peer-reviewed literature, and it's not something that we just, are supporting because it helps support our career. When I started in climate, I wasn't necessarily looking at climate change. I was looking at other parts of the climate system. But I realized that it was a major issue because I understand the climate system. And, what I've always discovered is that most people, and maybe this is a little bit too much of a, not stereotype, but, generalization, but most people that don't believe it, or at least they state they don't believe it, don't like the solutions as much as anything. They don't like the fact that, one of the major solutions is to reduce emissions. How do you reduce emissions? You stop burning fossil fuels in terms of coal but the economy is already moving that way. If you look at alternative energy, electric cars, energy being produced by windmills and hydropower and solar. I think there are actually probably more jobs in solar power than there are in actual energy production, and not extraction of coal and everything. But So the economy's changing, and there's a lot of scientific evidence to back it up. And I know people don't want to hear that. They don't, they're not going to understand it. But it's kind of like the smoking and lung cancer and heart disease link that was going on back in the 60s and 70s. I mean, eventually the evidence became overwhelming. We're at that point. I mean, the evidence is getting overwhelming, and you can't deny it. I mean, you look at the people in Texas. I was reading about the Houston mayor who says you can't really deny climate change now, because of what happened with Hurricane Harvey.
Right. So but would you say when we're thinking about teachers that the National Climate Assessment, both volumes, is I mean, if you want to get the state of climate science that is for you in your classrooms in the nation, one of the best places to go to get the current state of what's going on all over the system and what we're doing about it, would you say that that's the go-to resource for them?
Oh, certainly. I mean, that's really the intent of the National Climate Assessment, is to provide society, citizens, people, the information they need to understand climate change, why it's happening, how it's changing, and what are going to be the impacts. How can you adapt to it, and how can we have an impact on mitigating the climate change that we're currently seeing? All those are in there.
Right.
And it's the go-to source, and that's really the reason why it's one of the reasons in my mind anyway is why it's put together, is to be a major resource for teachers, city administrators, you name it, anybody that has to either teach it or plan for it.
Right. That's kind of everybody. Well, Dave, I think that is a great answer. That we probably should end here. We're a couple minutes after. I think that's probably a perfect ending. So thank you very much, everyone, for spending the time with the Clean Network and providing an excellent and I hope a very useful webinar for teachers and educators nationwide.
I agree. Thank you so much, Frank. I'm just going to jump in here really quick. If anybody's question didn't get answered, I put my email in the chat, katie.boyd@colorado.edu. If you want to follow up at all, please email me. We're happy to talk with teachers and try to get your questions answered. And remember to check out cleannet.org. Thank you all so much for attending. And thanks to Dave, Frank, and Luann for presenting. We really appreciate you all.
Okay. Thank you.
Thank you, everybody.
Bye.